just going to go over a quick introduction to solving differential equations. In this video, we're going to go over two examples of separation of variables. And I have this first ordinary differential equation here. We want to solve y prime is equal to y squared, y of 0 is equal to 1, and t is going to be within the closed interval 0 to 2. Okay, so let me just first rewrite our differential equation. Y prime is equal to y squared. And as the name suggests, we're going to separate these variables. Even though there's no t inside of this, we're just going to divide by y. We're going to divide by y squared, excuse me. So, dividing by y squared. And we are going to have, as our new equation here, y prime divided by y squared is equal to, since we're trying to separate the variables here, and we could see that there was no t value inside of here, I'm just going to write that the right side of this is going to be equal to 1. And now we're going to integrate both sides. I'm going to integrate the left side with respect to y, and the right side here with respect to, we're going to use with respect to t, so dt. The integral of the derivative of y divided by y squared, this is going to make negative 1 over y. The integral of y prime over y squared is negative 1 over y, and this is going to be equal to, this makes t, and then we have a plus c afterwards. And based upon this now, we need to solve for y, since y is here as an expression. We can multiply both sides by a negative y to move it to the right. This is going to make 1 is equal to negative y times t plus c. And then just to fully move everything over, we're going to divide by negative t plus c on both sides. So this is going to be written as y is going to be equal to negative 1 over, and actually I don't need parentheses for this, I don't know why I was just including that. Y is equal to negative 1 over, this is going to be t plus c. Now based on our initial condition, we have y of 0 is equal to 1, so we're going to plug that into the equation that we just found. So negative 1 over 1 plus c. And we need to solve for that. And actually I just realized this is supposed to be a 0, not a 1. Let me fix that. Okay, so y of 0 is equal to negative 1 over 0 plus c, and this is supposed to be equal to 1. So the only way that this is going to be possible would be if c is equal to negative 1. Otherwise we're not going to get a positive 1 out of this. So based upon this, thus our differential equation is going to be solved here as y of t is equal to negative 1 over t minus 1 for this particular example. Now for a slightly more, let's just say, involved answer, and this one I don't have an initial condition for, so this is just going to be a general solution as opposed to a specific one like we just did. That is, I want to solve here the derivative of y with respect to x of 3 times the square root of xy. And for this we want to separate the variables, just as we just did. And to do that, we're going to divide by the square root of y on both sides and move this dx over to the right and cancel it out from here. So we are going to get dy over the square root of y is equal to 3 times the square root of x dx. And we're going to integrate both sides. This left side is going to make 2 times the square root of y is equal to, this right hand side is going to make 3 times 2/3 times x to the 3/2 plus c. And just to slightly rewrite that so it's a little bit nicer to see, I'll do that right here. This is 2 times the square root of y is equal to, this should be 2x to the 3/2 plus c. And we could further divide by 2 since we have a 2 on both sides. Get rid of it. We are going to have, oh, and I should probably note actually before continuing, this 3 is technically multiplied by this entire thing. But because we don't really know what c is, and I might as well do that with the proper terminology on it. So this would be multiplied by 3c here. And when we divide by 2, we are going to get the square root of y is equal to x to the 3/2 plus 3/2 c. But of course, c though is an arbitrary constant. We don't really know what that is. We could though, very quickly, we now would need to square this, both sides of this. And we're going to come up with 2 cases now when we do this. If we have, so this should be 4, x and y both being positive. For x and y being both positive, this is going to be y of x is going to be equal to x to the 3/2 power plus 3/2 c squared, as you would expect, based upon this. Now, if we were to go through the route of taking negative values, so x and y being less than 0, that does change our differential equation slightly to the derivative of y with respect to x is equal to 3 times the square root of negative x times negative y. That does slightly change by putting a negative in front of both x and y throughout this equation, but the idea of it though is when we get down to our solution here at the end, we get y of x is equal to negative x to the 3/2 power plus 3/2 c. This would be squared. So the only difference it would make is just in terms of these extra negatives inside of it. But those are two examples using separation of variables within differential equations. Thank you.